For our next equation, we're going to be taking a look at this problem right here. 3 divided by a quantity x, taking away 5 positives, is equal to 8. But having that x as a denominator really kind of isn't too easy to read and start with the problem. So we're just going to rewrite it. We're going to rewrite it as 3 times the quantity of the inverse of x. Taking away 5 positives is equal to 8. We did not change the value of the original equation. We just rewrote it using a factoring technique. We factored out that 3 and made it an operation of multiplication. So similar to our previous problems, we're going to start out with a quantity. But now our original quantity is going to be the inverse of x. So this inverse of x, this unknown quantity, is going through a series of operations and is being related to a value and a quantity of 8. So the first operation that's happening to it is that it's being multiplied by a value of 3. After it's being multiplied by 3, there is another operation that's happening to it, which is there's 5 positives being taken away from that side. After those operations, it's being compared to the value and the quantity of the numerical value of 8. So I start with this inverse quantity. It gets multiplied by 3, 5 positives gets taken away, and it's being compared and equal to a value of 8. So in order to find my value of my original unknown quantity, I need to make my way back through the problem by applying the inverses. So the inverse function, or the inverse operation of what's happening to the equation, is the first one that we meet on this line. The inverse of subtraction is addition. So if I take away 5 positives, I can turn around and add 5 positives, and that creates 0. Actually creates 5 sets of 0 pairs. 0 is the additive identity. So whatever I do through subtraction, I can turn around and undo by the use of addition. I'm creating 0 pairs. Similar to addition, when I take a look at my next line, the inverse function is actually being multiplied by 1/3. Well, that's because the multiplicative identity is 1. If I increase a value 3 times as much, I need to turn around and get that down to 1. So I'm going to increase the value 1/3 amount of times. Multiplied by 3 and then multiplied by 1/3 actually creates a 1 pair. So I used the operation and then I used the inverse operation. Building them all together, starting with my second quantity, my second value, and then I'm adding 5, I get 13. And then applying that multiplied by 1/3, the solution is that the inverse of x is equal to 13/3. The inverse of x is equal to 13/3. But our goal wasn't to find the inverse of x. Our goal is to find the value of our unknown quantity, x. So I'm going to apply the reciprocal to the inverse. 1 over x and x over 1 are reciprocals of each other. They themselves are multiplicative inverses. So if I apply the multiplicative inverse to 1 over x, I'm going to apply it to the solution as well. 13/3 becomes 3/13. So the value of x and the solution of my equation is 13/3. So now that we have our solution, you can see that I wrote the equation twice, the original way that it was expressed, and then the way that we rewrote it, so we have a comparison of 3 times the inverse of x. We're going to prove that the solution fits for both equations, just so you know that we really didn't change anything mathematical. So I'm going to input my solution into my equations similar to the function composition. I'm just going to substitute in these values and simplify, and we should get the values to be equivalent. So 3, substitute with the x, which is 3/13, taking away 5 positives is equal to 8. 3 divided into 3/13. So for each one, there's going to be 13 sections, and of that, I'm going to multiply that by 3. So that actually simplifies to 39/3. And I'm going to take away 5 and is equal to 8. 39/3 simplifies to 13/1. Take away 5 is equal to 8. So 13 subtract 5 is equal to 8. So 8 is equal to 8. It works. It's true. On the other side, same equation, different way that we wrote it, different way that we expressed it. I'm going to replace my value for x. 3 times the quantity, 1 divided by 3/13. Taking away 5 positives is equal to 8. I'm going to simplify my inverse and see that 1 over 3/13 is actually 13/3, and 3 times 13/3, take away 5 positives, is equal to 8. I'm going to apply multiplication, and 13/3 of 3 would be 39/3. Taking away 5 is equal to 8. Similar to the other side, I know that 13/3 can be reduced to 13/1. And then 13 subtract 5 is equal to 8. And 8 is equal to 8. So again, we maintained equality. We maintained the truth. So the solution works.